Hello, everyone. Thank you for joining us this evening for the ISO 3834 audit process webinar. My name is Ash. I'm a welding engineer with the Weld Australia engineering team based in Sydney. Also a lead assessor for ISO 3834 in New South Wales. Today, I'll be giving a talk on the ISO 3834 audit process. I'll begin with an overview of AS/NZS ISO 3834 to give you an understanding of the standard's purpose and scope. We will then move into the certification process and cycle, outlining key stages and timelines. After that, we will break down the audit process step by step, following each clause of a standard. And we will also look at the quality assurance documentation required for compliance. And finally, we will cover the essential workshop personnel and qualifications needed under the standard. The standard ISO 3834 outlines the production control requirements, specifically for fusion welded products. It integrates these controls directly into welding management system, helping ensure consistent weld quality. And the standard takes a structured approach, covering all phases of welding, from planning through to inspection. So to clarify, ISO 3834 is not a product standard like AS5131, like AS4100 for steel structures. It doesn't define technical specs of the product, but rather focus on the quality process behind the fabrication. The standard ISO 3834 has a long history, and it was first introduced in Europe in 1994 as EN 729 and became an international standard in 2005. Australia adopted it in 2008, and today over 111 companies across the country are certified to this standard under IIW Manufacturer Certification Scheme. The standard consists of 6 parts. Part 1 helps select the appropriate quality level. Part 2, 3, and 4 outline the comprehensive, standard, and elementary requirement, respectively. And Part 5 covers the documents needed for conformity to each part. Part 6 also provides guidance on implementing all these requirements. The process, the certification process, starts with issuing the proposal and completing the application form. Stage 1 involves a desktop assessment with supporting documents, especially company procedures. Stage 2 is the site audit, typically 2 days for certification and 1 day for surveillance audits. And finally, stage 3 includes reviewing corrective actions and issuing certification after ANBCC independent review, authorized national body for company certification. The IIW MCS ISO 3834 certification follows 5-year cycle with annual surveillance audits. It starts with the initial certification in year 1, followed by yearly audits from year 2 to year 5. In year 6, a full recertification audit is conducted, and the cycle continues, starting with another surveillance audit in year 7 after recertification. QA documents are classified into three main types. Company procedures outline how each ISO 3834 clause is applied and can be standalone or part of a quality manual. These are typically reviewed during desktop audits. Audit forms and checklists support the procedures and are used to record quality data. For example, technical review checklist, WPS-PQR forms, supplier evaluation forms. Registers track important items like assets or non-conformances, material traceability. Both forms and registers are verified during the site audit. And the audit process follows ISO 3834 starting from clause 5 for technical review to clause 18 for quality records covering key areas. Before each clause of ISO 3834, before reviewing each clause of ISO 3834, it's important to understand part one of the standard, which outlines the criteria for selecting the appropriate quality requirements. Annex A, if you go to Annex A of this part, is especially useful. It shows what QA documentation is needed, what level of documentation is needed at each certification level. For example, Part 2, the comprehensive level requires extensive quality records. Part 3, the standard level requires fewer records, only where specified or requested by the client. Part 4, the elementary level, has minimal requirements and is rarely used in Australia. Most fabricators and manufacturers aim for Part 2 or Part 3. Clause 5, we go through each clause and we will present what we will verify during the audit and what is the compliance, what QA documentation we will verify during the audit. Clause 5, review of requirements and technical review. When a contract is accepted, both parties, manufacturer and client, take on full responsibility and accountability. So it's essential that the manufacturer clearly understand all requirements. The aim here is to ensure manufacturer can meet their technical expectations and deliver the product exactly as agreed in the contract. So the review requirement ensure the company can meet all customer needs, including technical and delivery aspects. Typically, the project manager leads this with the welding coordinator involved for welding related items. And it considers product standards, regulations, any additional manufacturer requirements, and the company's capability to fulfill them. As you see, I have extracted the section 5.2, clause 5.2 from the standard, and we have 4 key items that needs to be considered during this stage. The technical review, clause 5.3, focus on the contract's technical aspects and involves departments like design, welding coordination, and QA/QC. The key points here include reviewing technical information like parent material specifications, weld quality criteria and acceptance criteria, weld accessibility, inspection, welding procedures, ensuring proper qualification of both procedures and personnel, etc. And to demonstrate compliance in this clause, clause 5.2 and 5.3, companies must have documented company procedures for both contract and technical review. Supporting evidence here include completed checklist for each review, for each job, each project, signed by the responsible welding coordinator. And this confirms the manufacturer fully understands the requirements and is capable of meeting them. I have listed some common issues in each clause. When we go through each clause, I will present some common issues that I came across during the audits. Here in review of requirements, common issues include having no documented procedure, no involvement from the welding coordination team, unclear roles and responsibilities, and missing records or checklists to show that what was reviewed.
Excuse me, Ash, we've just got a question here.
Yeah.
The question is, documented procedures for review of requirements and technical review is really required?
That's a very good question. Yes, the procedure is required. The best guide to see the requirement is part 1. If you go to the part 1 of the standard, there is a table that explains for each quality requirement, for example, for quality requirement, comprehensive quality requirement, what we need to do. If we need to comply with the part 2 of the standard, we need to have a procedure in place. And the procedure, the company procedure, needs to detail and explain what we need to consider during this stage, and reflecting the information from the standard, the clause 5.2 and 5.3. Yes, the company procedure is a mandatory item, and most importantly, the checklist, contract review and technical review checklist needs to be referenced in the procedure. And for each job, the technical information needs to be captured using these checklists. Okay. Clause 6, subcontracting. Subcontracting is common for activities like NDT, post-weld heat treatment, inspection, or testing due to cost and convenience. But the manufacturer remains responsible and must provide subcontractors with all necessary technical information and ensure they are capable of meeting the requirements of the ISO 3834.
Hi, Ash. Sorry, another question. Are those checklists required for every job?
Yes, the checklist required for every job. Let me go back to this slide here. Okay. As you see here, the first item, review of requirements, second item, technical review. If the company is going to get part 2, ISO 3834 part 2 certification, as you see, record is required. So record is the checklist. Regardless of the project and the value of the project, if the company wants to comply with the part 2 and the scope of the production needs to comply to the part 2, the checklist needs to be provided. For part 3, as you see, record can be required. When we say can be or if required, it's just about client requirements. If you have any client and that client doesn't mandate a technical review checklist or contract review checklist, that's your option. But if you're complying with part 2, the comprehensive quality requirement, checklist is a mandatory. And checklist needs to capture all the details extracted from different documents. For example, if the welding standard is AS/NZS 1554 part 1, a structural purpose, you need to specify that in the checklist. And anything else with respect to the parent material, joint preparation, and so on. So this table from part 1 is a very useful reference to know what we need to prepare and what we need to provide during the audit.
Sorry, I've got another question.
No worries.
In this table, record is required for both, but not where it is stated documented procedure is required. Was that
Yeah,
not?
the table doesn't provide details about the document, but when we say, as you see, review required for both review of requirement, technical review, but record here means two type of document. The first document is how you make this record, and that's about the procedure. And procedure is something you develop once. You don't need to develop it multiple times. It just gives you the guideline how to do the contract review. And the best source to develop your procedure is the standard, clause 5.2 or 5.3 details. The second type of the record is a checklist, because for each specific job, uh, you need to extract those information and reflect in the checklist. Yes, the table doesn't display these terms, but to verify that the procedure is in place and checklist is in place, we need both documents to comply with part 2. Okay.
Sorry, I've got another question.
No worries.
Is it sufficient in every job or project? Sometimes clients have their own specification to outline the clause 5, both review and technical review.
Yes, client requirements is very important, but when it comes to part 2, as I said, part comprehensive level, the standard, the ISO 3834 is the first priority, and we need to comply with whatever here we need to record. But when we have part 3 in place and the company has a certificate for part 3, the first priority is the client requirement. If the clients say they don't need, for example, any record for one of these clauses, if there is a if required or if can be required, manufacturer doesn't need to provide that. But part 2 is the stringent one, and regardless of client's specification and requirement, because it's a higher level of specification.
Thank you.
No worries. Okay, and subcontracting, that's common for activity like NDT, post-weld heat treatment, and the manufacturer remains responsible. To demonstrate compliance, a manufacturer must supply all relevant technical specification and evaluate subcontractor capability and maintain approved supplier list. So the performance history should be reviewed regularly. Supporting QA documents here include a documented procedure for part 2 again, and approved subcontractor list should be provided, and initial and reevaluation checklist are needed to record the evaluation of the suppliers. Common issues here include limited communication between the fabricator and subcontractor. For example, in NDT, there is often no standard or acceptance criteria shared. In purchasing, key details like steel grade is missing. For post-weld heat treatment, procedure is missing, for example. And there is also a lack of subcontractor capability checks and no process to monitor their ongoing performance. And these are some major issues that I came across during the audits. Clause 7, welding personnel. Welders must be properly qualified in this clause for the specific tasks they are assigned, and welding coordinators must be competent and involved throughout the manufacturing process. They play a key role in controlling the welding activities. So if welding coordination is outsourced, a formal agreement must ensure their involvement, authority, and independence. So inspection personnel should also be available as needed based on the client needs. And the roles and responsibility in this clause, the roles and responsibility of the welding coordination team must be clearly defined as outlined in ISO 14731 Annex B. That's the reference standard here. And the welding coordinator must have the authority to make independent decisions, including stopping the production if welding is done incorrectly. In smaller business, tasks can be delegated as long as the person assigned has the right knowledge and competence. For example, for some activities like storage and handling of consumables and materials. This is an example of organizational chart. That is another important document that we verify as evidence during the audit, where the responsible welding coordinator in this example is the IWE, International Welding Engineer. The RWC, Responsible Welding Coordinator, takes overall responsibility for all welding related activities, including specific tasks outlined in ISO 14731 as the reference standard. So to demonstrate compliance in this clause, we need to verify key records such as valid welder qualification records, qualification of welding coordinator, and organizational chart that clearly outlines the welding coordination structure. Supporting QA documents should include a documented company procedure, again, a roles and responsibility matrix based on the ISO standard, ISO 14731. And if welding coordination is outsourced, a formal contract and a log of activities that show that the responsible welding coordinator is actively participating on site activities and welding coordination activities.
Ashkan, sorry, I've got another question. Can the welding coordinator be outsourced for part 2, i.e. a subcontractor?
Yes, the welding coordinator can be outsourced. It doesn't matter you are complying with part 2 or part 3. You can have a responsible welding coordinator, let's say external consultant, external welding coordinator. But the key requirement is they need to have a contract. They need to have a log of activity during the over the month and the time that they are doing the activities there. Yeah, it doesn't matter it's part 2 or part 3.
Thank you.
Yeah. And so there is no mandated qualification for welding coordinators under current edition of ISO 14731, but courses like IWS, International Welding Specialist, IWT, International Welding Technologist, or IWE, that's the highest level, International Welding Engineer. All IIW courses are highly recommended as they align with the standard expectations. Competency of the welding coordinator is also assessed during the audit by interview, and other recommended qualifications are AS2214 welding supervisor for steel structures and AS1796 certificate 10 for pressure equipment scope. And these are the common qualifications for RWC responsible welding coordinators, whether they are internal or external in Australia.
Ashkan, another question. In a small company, can the welding coordinator also be the welding supervisor?
Yeah, it can be the welding supervisor as well. That's not an issue, as long as the roles and responsibilities are defined and allocated properly based on ISO 14731. And if the welding supervision has lots of activity, the welding coordinator should be full-time and spend enough time to manage the activities. For example, if the welding coordinator is external and let's say participates on site 2 days per week, maybe it's not enough to do the welding supervision activities as well. And this is the most important thing.
Thank you.
And common issues here include welders being qualified to outdated or irrelevant standard and lacking a proper system to track their qualifications. Often there is no review of specific client requirements, no clear role allocation, and no organizational chart to define responsibilities. And these are the main issues resulting in NCRs or observations during the audit. Clause 8, inspection and testing personnel. Manufacturer must have enough qualified staff to oversee welding, inspection, and testing. So NDT technicians need to be certified to ISO 9712 level 2 through AINDT Australian or BINDT British one or equivalent. And for visual testing, a qualification test is not always required. For NDT personnel, competence shall be verified by the manufacturer. Also, compliance is shown through valid qualifications, proper training for in-house inspectors, and also meeting any specific client or project requirements. QA documents here include documented company procedures to clarify the procedure and valid NDT certificates for the NDT personnel. For example, if a fabricator outsource NDT activity like PT, MT, UT, RT, they need to make sure the NDT personnel have valid NDT certificates in compliance with ISO 9712 level 2, the minimum requirement for the part 2 of the standard. Common issues for the inspection and testing personnel include the use of unqualified or untrained personnel, and no formal process for personnel approval, unclear roles and responsibilities, and lack of activity records like NDT records, NDT reports. Clause 9, equipment. Standard requires that suitable equipment and associated tools like power source, wire feeders, inspection instruments, and rotators are available and maintained. So it's essential to have a system in place to prevent the use of faulty equipment that could affect the product quality. So compliance is demonstrated through a documented company procedure and maintenance plan. Equipment list like asset register and maintenance checklists to be completed routinely, focused on items critical to quality like power source, wire feeders, welding machines, and so on. Large equipment.
Ashkan, we have another question. Generally for VT, how to determine the competency when ISO 9712 is not mandatory?
Yes, for the visual testing, there is no requirement, no formal requirement, and the inspector, whether he is or she is internal or external, doesn't need to provide a certificate, but the competency can be assessed by the welding coordinator, and the knowledge test needs to be examined based on the requirements of the product. For example, if the product is complying to the pressure equipment codes, like AS 4041 for pressure piping or AS 1210 for pressure vessels, the inspector needs to know how to do the visual testing for these products. And they need to have enough experience how to do and how to work with standards for pressure equipment. If the product is structural steel, that's different. The inspector needs to know the details about steel structures, like AS 4100 for bridges design, AS 1554 part 1, 2, 3, or 4, 5, and even 6 for stainless steel for the welding standards, and how he can interpret the defects or let's say discontinuity during the inspection based on those requirements. So what I suggest here is for the VT, you need to have a look at your scope and see what's your scope of work. If it's a structure, you need to make sure your inspector knows all details about that field, because that's a broad field. We have a steel structure, we have pressure equipment, and anything else.
Thank you. We've got a couple of more questions. Regarding procedures, will client procedures be acceptable instead of internal company ones?
That's the responsibility of the fabricator to provide the procedure, because when you get your certificate, your ISO 3834 certification, for example, in compliance with part 2, in your certificate, you don't list the name of the client. You just list the product type. We list the product standard. We list the welding standard, welding process, material groups, and welding coordination team. So because you are under qualification of the ISO 3834, for example, part 2 or part 3, you need to provide your own procedures. You can get some idea or get some information from the client what you need to include in your procedure, but the final responsibility is with you. And the certificate needs to reflect, I mean, the ISO 3834 certificate reflects your compliance with the quality requirement regardless of your client. You may have this client this year and next year another client. So the procedure needs to be designed by yourself.
Thank you. One more question. CSWIP 3.1 welding inspector is also accepted for welding coordinator.
For the welding coordinator, typically inspection certification is not sufficient. If the welding coordination is having the just inspection certification like CSWIP, or in some instances, let's say, let's take a better example, IWIB, IWIC, even IWIB International Welding Inspector Basic level or standard level, IWIS. It's not enough for the welding coordination. Welding coordinator is someone who wants to manage the welding activities, not just the inspection. So the best approach is to comply with the welding supervision course or qualification like AS 2214 or AS 1796.
Thank you.
Yep. Okay, so equipment standard requires that suitable equipment and associated tools like power source, wire feeders, inspection instruments, and rotators are available. And because it's essential to have a system in place to prevent the use of faulty equipment. Compliance is demonstrated by a documented company procedure and a maintenance plan, equipment list, and maintenance checklist. Common issues here in Clause 9 equipment include no documented procedures, missing asset registers, and unchecked maintenance. Often staff are not aware of what equipment is available for how to maintain it properly. This is another issue. And Clause 10, welding and related activities. So fabricator must ensure proper production planning of welding and related activities. In some cases, this planning is integrated into the inspection and testing plan, ITP, which are linked with drawings. And key elements include defining the sequence of welds, referencing the correct WPS or work instructions, organizing the order and timing of welding, specifying inspection and testing requirements, and assigning qualified personnel to each task. So welding procedure specifications or WPS must be prepared, qualified, and used correctly according to the product standard. Sometimes work instruction based on qualified procedures are used instead of WPS directly for welders because it's easier for some welders to work with. Compliance here means having valid practical WPS that welders follow and that meet requirements of the welding standard or code requirements. So random checks during the audit verify the welding variables match the qualified procedures during the site visit. And common issues here in Clause 10 include no production planning, missing shop floor information, no procedure available for developing WPS PQRs, I mean company procedure, and WPS or PQR documents not available in the workshop. That's another common issue that happens. Clause 11, welding consumables. Control of consumables is critical, especially when they are affected by environmental conditions like moisture. And a documented procedure must cover how consumables are received, stored, and handled. And staff involved must be trained and always follow they need to follow the manufacturer's guideline. I mean, the consumable supplier guidelines, because that guidelines define how they need to store it and handle it.
Ash, sorry, I've got another question. One equipment, ISO IEC 60974-14 must be complied. And the periodic asset validation every 6 months or yearly.
Okay, so I will answer this question in clause 16 for the calibration and validation. But yes, the IEC standard is the reference standard, and welding machines, power sources needs to comply with the calibration or validation procedure in that standard. And they are typically verified annually. Yeah.
Thank you. And another question, sorry. WPS should be followed as per ASME 9 and AWSD 1.1.
It depends on the product requirement. So when you get the ISO 3834 certificate, you need to clarify what's your product, what's your scope of product. If, for example, you have ASME 9 as the welding standard in place, it means that your product is a pressure vessel or pressure piping based on the American standards. So if the product is pressure piping or pressure vessel, yes, WPS needs to comply with the requirement of Section 9 of ASME. That's for the qualification of the welding procedures and personnel, welders. But if the product standard is structural steels, yes, the WPS needs to comply with AWSD 11. That's the American standard for steel structures. So the answer is about what's your product and what's your product scope. And the other thing is if for example, you have WPS to ASME 9 or D11, during the audit, we need to verify a couple of WPS, at least a couple of WPS PQRs and a couple of welder qualifications to that standard to make sure the company, the fabricator is competent and is complying with the requirements of that standard in order to list that standard in your scope of certification. Okay. Welding consumables, common issues here include no dedicated storage area, leaving consumables exposed, and traceability is lost, for example, for TIG rods and GMAW wires, open boxes of MMAW electrodes and flux core spools that cause contamination risks. Cross-contamination and gas supply problems are also common issues in this section, in this clause. A storage of parent material, clause 12. Parent material must be stored to prevent environmental damage and cross-contamination. Traceability must be maintained using markings such as heat number, job number, or any other identifier, as well as material certificates. So this helps reduce the risk of using incorrect or damaged material. Common issues here include no dedicated storage area for offcuts, resulting in lost traceability. Steel plates often show signs of pitting, mixing of carbon steel, stainless steel, aluminum alloys result in cross-contamination. So we verify your storage condition during the site visit to make sure you are complying with these, the requirement of this clause. And another issue is sometimes materials are frequently stored directly on the ground without assessing their condition. For example, whether they are stainless steel or carbon steel, and if you have assessed the cross-contamination risks for that material. Post-weld heat treatment, clause 13. PWHD is the manufacturer responsibility in terms of the specification and performance, and the procedure must suit the parent material, the weld, and the construction. So it has to comply with the relevant product standard or any specified requirements. A record like a PWHD report must be kept during the process, showing compliance and ensuring traceability to the specific product. In terms of the QA documents here, for part 2, the comprehensive level, and part 3, as you see from the table extracted from part 1, procedure and records are required. So the procedure can be provided in the WPS for that joint or a separate document complying to the product standard. So procedure and record, two key elements here if you want to include PWHD in the scope of your certification. You can exclude it, but if you want to include and say you comply with the requirement of the ISO 3834 for post-weld heat treatment, and these two items are mandatory for both part 2 and 3. Common issues here: having no documented procedure, no records or report maintained. And there is also non-compliance, sometimes non-compliance with the ISO 17663. I have extracted this table from part 5. That's reference the applicable standards for each section. There is sometimes non-compliance with ISO 17663, which outlines the required details for PWHD records and the procedure for furnace calibration. So in that standard, you can see how you can develop a record and a report for the post-weld heat treatment, and what elements, what critical elements you need to include in your record for each component, and with the traceability requirement. Clause 14, inspection and testing. Inspection and testing need to be carried out at key stages, especially before, during, and after welding, to ensure conformity with contract requirements. ITP is a powerful tool here, and QA documents that we verify during the audit here provide evidence of inspection, such as checklists or reports at each stage, before, during, and after. For both part 2 and part 3, inspection before and during and after is required, as you see from this table extracted from part 1. And common issues again here include a lack of understanding of the checks required at each stage. For example, if your internal welding inspector is not quite familiar with what he needs to do and what he needs to inspect, that would be one of the issues. Insufficient inspection tools, no record being maintained, and lack of company procedures, again, because company procedure is the basis to define what you need to do. For example, what your internal inspector needs to do. So your internal inspector can go to that inspection, that company procedure, and see the details. What's the reference standard? What's the test standard, to make sure everything is done properly.
All right, Ashka, we have another question. Can we use the PWHT procedure of subcontractor? Usually NDT companies offer that service.
Yes, the post-weld heat treatment can be subcontracted, but you need, at the end of the day, the final responsibility is with the fabricator, with the manufacturer. You need to make sure your subcontractor is complying with the requirement that I discussed. Like the report they are providing is following the ISO standard, ISO 17663, the requirements of that standard. So this needs to be done, this needs to be evaluated during your subcontractor evaluation. When you do the evaluation, you need to make sure that service provider is competent and is able to comply with your requirement.
Thank you. So another question. What is the competency of personnel for signing inspection reports?
Yeah, the competency of the personnel for inspection report, if that's a visual inspection, as I said, the inspector doesn't need to have a specific qualification. But if it comes to NDT, like a PT, MT, UT, or RT, the minimum requirement is level 2 ISO 9712. And this is the standard that is referenced in part 5 of the standard. Yeah.
Thank you.
Clause 15, non-conformance and corrective actions. Non-conformance control involves managing items or activities that don't meet requirements. Repair and rectification procedure must be available at workstations, and repaired items should be re-inspected and retested according to original specifications. Measure must be implemented to prevent recurrence, and also QA documents here include NCR register, what we verify and is very important, is NCR register, because your NCR register is displaying the status of your NCRs over the years. And NCR corrective and corrective action form. So for each specific NCR, you need to complete that form and detail the problem, corrective action, and preventive action. And these are two main documents that we usually verify during the audit, especially for part 2. Common issues here include lack of company procedures for handling NCRs, lack of NCR registers and records, and no repair or rework procedure in place. Because if you have an NCR and the corrective action needs a repair, you need to have a procedure in place. Sometimes the WPS you have for production doesn't cover the repair welding. That's why when you have a repair or rework, you need to make sure you have a procedure for that specific repair. And if any specific WPS is required, for example, if you have a buildup due to excavation of the defect, you need to develop that procedure and WPS to make sure it works properly. Clause 16, calibration and validation of equipment. Yeah, here all equipment used to assess quality must be properly controlled. Calibration and validation should be done at defined intervals. As I said, for example, for the welding machines, annual calibration, whether it is internal, it is conducted internally or externally, annually is fine. And this includes welding machines and measuring tools. Welding machines must comply with IEC standard, IEC 60974 part 14. And this is a mandatory requirement. But for part 3, as you see in this table, is if required. If required means if your client mandates the verification of your welding machines by a calibration or validation procedure, you need to comply with that. Otherwise, yeah, it's up to you.
Ashkan, we have another question. Can WPS for butt welds, can they be used for repair welding?
Depends on the standard. For example, if your welding standard is ISO 15614, if you go to that section, you can see you can use butt weld WPS for repair welding. As long as the WPS is supported by a PQR for that specific work, that's okay. You need to have a look at your welding standard and what standard you are complying with. If that standard permits and allows you to use that WPS with that range of qualification, you can use that for the repair welding. Yeah.
Thank you.
Yeah. So calibration or validation includes welding machines and measuring tools. Welding machines, as I said, need to comply with the IEC standard. And for the part 3, it was if required, but for part 2, it was mandatory. Calibration involves verifying the equipment, reading against the display value, for example, for welding machines. Validation checks the performance against the set value. So there is a difference between these two terms. We verify the welding machine with one of these methods: calibration, validation, or consistency tests. So the term of verification is the final outcome, but the technique or the method or the procedure that we use that depends on the power source is either calibration or validation or consistency test. Consistency test is also performed to ensure reliable operation, but the choice of the verification technique depends on the power source and whether it provides a display value and or a set value or uses some arbitrary units. If you have a look at this flowchart that I extracted from the IEC standard, there is a very clear pathway to the appropriate technique and the appropriate method. For example, if only display value is available, we do the calibration based on the display value.
Sorry, Ashkan, we have another question. If required, can be used as customer requirement, product standard requirement, and statutory and regulatory requirements all put together, or only one?
Yeah, we can put that together if that covers both requirements, both standard requirements.
Thank you.
If there is any overlap, in most instances there is overlap between both requirements. And common issues here in this section is lack of company procedure for equipment calibration to clarify how to do the calibration or validation based on the IEC standard, no records being maintained for each welding machine, for example, and limited knowledge on how to carry out the calibration procedure, what I typically see these days, because you need to have a very detailed look. If you do it internally, try to read the standard, IEC standard, to make sure you are doing that properly and your company procedure is properly displaying that requirement. And clause 17, identification and traceability of welding operation must be maintained throughout the project as defined by the client. Key items to verify here include traceability of the parent metal and welding consumables. So the extent of the traceability is decided by your client. If, for example, your client needs to comply with AS NZS 1554 Part 1 for the structural steels, the extent of testing, as you see in the standard, is 10%, for example, for VT, PT, RT, NDT tests. So the extent is not 100%, and it needs to be captured in the technical review stage and contract review stage. If your client mandates any specific extent of traceability, you can follow that.
Another question, sorry, Ashkan. Calibration and validation of equipment. If the welding machine doesn't show the actual value of parameters, not digital, can the verification of the values be done using calibrated clamp meter to get the right number?
Okay, if the power source doesn't display, if it doesn't display any value and it has only some selectors to set the value, you can do the validation. You cannot do the calibration, because the concept of the calibration is to compare what you read on the clamp meter with what is displayed on the screen of the power source. When you don't have that option, you need to do the validation. So what you do is you compare the value you read on the clamp meter with the set value, that selector that you set the value on the machine. If that selector shows, for example, directly shows the parameters like amp or volt, that's validation. Otherwise, if the selector doesn't set the actual values, it just sets some arbitrary units like 1, 2, 3, 4, 5. It's about arbitrary units, and we need to do consistency tests. If you go to the IEC standard, the standard defines how you do the consistency test in this case.
Thank you.
Common issues in clause 17 include no procedures in place, lack of traceability, heat numbers not transferred to the offcuts, and mixing of different consumable batches. And the final clause, clause 18, quality records. Record type and amount depend on the internal and external factors. Internal factors include process monitoring, welder performance, but external factors cover client requirements and regulatory standards. Some common issues here include no records being available, like the MDR, absence of procedures, no defined list of records to maintain, and lack of standard manufacturing data record MDR when required and mandated by client. If the client needs that requirement, you need to prepare MDR, and MDR is the final book that collect all the data, all the inspection activity, all the activities during the production, not only for the welding, for other things, and you can provide that pack of documents as a final book or final MDR for the client. And I think this is a very brief description of each clause and what type of QA documents we need to comply with here, and some common issues and observations or NCRs that we came across over the last few years. Thank you.
Thanks, Ashkan. We've got some really good comments here, a very good explanation and very informative. So thank you very much,
Thank you.
Ashkan. Are there any more questions from anyone else? If you have any questions at a later date, you can email events@weldaustralia.com.au. Or myself, my name's Charlotte, I'm the event coordinator, and I can forward those on to Ashkan and get your questions answered. Otherwise, thank you very much, everyone.
Thank you.
And have a good evening. I'll stop the recording. Thank you.